Hey everybody, Mr. Bucko here with a couple of problems from your Chapter 5 self-test. I have numbers 1 through 3 on this particular video here, so we'll start at the beginning. So we have number 1 and 2 where we are referring to the figure that we have here, which is RPTMB is congruent to SFLWB. So basically this kind of diamond looking figure, I guess, for the lack of a better term, is congruent to this one down below. And we know that the measure of angle T, or we're told that the measure of angle T is 125 degrees, which other angles measure must also equal 125. For this we can kind of look at the picture and kind of see where it matches up. In this case it might be easier just to use the congruent statement here. And we're saying that if angle T is 125, there's another corresponding angle that is also 125. And if we look in this statement of the figure, RPTMB, T is the third vertex. On this side, or in this figure, L is the third vertex. So T kind of maps to L. And that's easier probably to see in the congruent statement than it is in the figure. So we would say that which angle is also 125 degrees, that would be angle L, because yeah, it looks like it, but again, that's not a great justification. F maybe looks like it too, but we can say with certainty that T and L are both 125 because they're in the same place in the congruent statement. Which other segment must be congruent to SB? That would be this segment here, and we can say, well, there's a couple of them that look congruent to SB just looking at the figure. But if we go back to the congruent statement, SB, S is the first one, B is the last vertex in the statement, so SB would correspond to the first and the last. So SB would correspond to RB. So which other segment must be congruent to SB? That must be segment RB, because they are in corresponding spots along with SB. Number 3, in the figure below, we have the measure of angle 5 is 37 degrees, or we are told that. And we are also told that line L and M are parallel, and we want to find the measure of angle 2, and we want to justify our answer. So we know that this angle right here is 37 degrees, and when I look at this figure and just kind of knowing the things that I know about parallel lines and transversals, if angle 5 is 37 degrees, angle 1 must be 37 degrees. And how come I know that angle 1 must be 37 degrees also? Because that's a corresponding angle, and in particular it's a corresponding angle with respect to parallel and transversal lines. So angle 1 is 37 degrees, but I don't want to know angle 1, I want to know angle 2. But if I look at angle 1 and angle 2, these two are a linear pair. They are on the same straight line, so angle 1 plus angle 2 is going to be 180 degrees. So I can do 180 degrees minus 37. That will give us 143. And the reason I can do that is because angle 1 and angle 2 are a linear pair. Therefore, they are supplementary angles. They add up to 180. So, with that being said, after doing that subtraction, I can say that angle 2 is 43 degrees.